This PowerPoint is an extension of video topic 3. This is video topic 3B if you're following along with the note guideline. This is just an overview of what we've already talked about. We have discussed batteries and voltaic cells in video topic A, and now we're going to get into the electric circuits, how to measure them, and electrical resistance. Next week, we'll be talking about the electricity at home, energy efficiency, and sustainability. Here's some terminology that you need to know before jumping into beginning to build a circuit. So you guys have already had your hands on a lot of these tools and instruments and devices, and you were able to actually set up your own circuit without even knowing what some of these things were called. So now it's important to put a name to those different types of instruments. So we know that a battery has a positive and a negative terminal, the positive being the cathode, the negative being the anode. A terminal is the part of the cell that's connected to the other parts of the circuit. Generally, it's connected to conductors to allow that electrical current to flow through the circuit. A switch is a control device. It can make or break the circuit. An open circuit has a break or a gap in the circuit, and a closed circuit is a continuous loop where the current will flow. In class, I talked about the analogy of a drawbridge, or if you think about the San Francisco Bridge, if you put your hands together in front of your face, middle fingers tip to tip, and you've got like a horizontal with your arms, pretend that your hands are the bridge gates, and the cars drive over the bridge continuously. So that could represent the electron and the current, the electron flowing through the circuit. The bridge is going to open up when something needs to go through it. So as soon as your hands open up, it stops the cars from moving any further. So it'll stop those cars, and if we're comparing it to the electron analogy, it will stop the electrons from flowing. So looking at the next image, can you determine whether the light bulb will be functional or not? It has something to do with the switch. So if you take a look at the switch, this is an open switch. It's kind of like that bridge analogy we were talking about. The bridge is open. Can the cars travel across? Can they get across to the next side? No, they can't. So in this case, the light bulb will not light up because the electrons won't be flowing. It's not a complete circuit. So what type of circuit is this? Open or closed? It is considered an open circuit. And last but not least, which light switch does the above diagram represent? If you think about it this way, you've got your light switch in your house and you push it down to turn it off and you push it up to turn it on. Well, in this case, we are turning off the light. So the light isn't even on yet. So in this case, the circuit represents this light switch. In the next video, we're going to be talking about resistance, potential differences, current, and other interesting things.